Hi, in this lesson I am discussing Edexcel IAL October 2021 Physics Unit 5 paper. Okay, the first question, which of the following describes a standard candle? We know standard candle means an object, astronomical object with known luminosity. It could be a Cepheid variable or like a type 1 supernova is used as a standard candle. So here the four answers are given. First one, a star of known distance. Second one, a star of known intensity. Third one, a star of known luminosity. So you know standard candle mean a star of known luminosity. For the first question, correct answer is C. Okay, the second question, a helium nucleus approaches a gold nucleus. An electric force and a gravitational force act on each nucleus. Which statement about these forces is not correct? First one, the electric force between the nuclei is repulsive. So that is true because you know alpha particle helium nucleus is positively charged. The gold nucleus also positively charged, so there will be repulsive force. So our first statement is a correct statement. We want a wrong statement, so that is not the answer. Second one, the electric force is always smaller than the gravitational force. Okay, that we can't compare always, they are saying. So that depends on the, you know, when you consider gravitational force F equal G m1 m2 r squared, and electrostatic force is F equal K Q1 Q2 R square. So without knowing the values of M1, M2 and Q1, Q2, you can't compare the magnitude of gravitational force and the electrostatic force. So the wrong statement is B, and we want the wrong statement. So the correct answer for question number 2 is B. Okay, question number 3. The gravitational field strength at the surface of moon is 1/6 of that the surface of the earth. A simple pendulum has a period capital T at the surface of earth. What would be the time period of the same pendulum at the surface of moon? So there are four answers given. So we know that for simple pendulum, the period is given by T equal to pi square root of L over G, that is on the surface of Earth. On the surface of Moon, G will be 1/6 of it. So I can say T1 on the surface of Moon, 2 pi square root of the same pendulum, same length over G over 6. So 6 will go to the numerator. So that will be 2 pi square root of 6L over G. Okay. So you can divide this by this. Or if you want, you can write this again like square root of 6 into 2 pi square root of L over G. Nothing. So this 2 pi square root of L over G is T. So that will be root 6 T. So T1, the period of the same pendulum on the surface of moon will be T into root 6 or root 6 times of T. So the correct answer is D. D is given as T into square root of 6. That is the correct answer. Answer D for question number 3. Okay, question number 4. Cancer cells inside the body can be killed by directing narrow beam of radiation from the different directions onto the cells. The source of radiation is outside the body. Which radiation would be the most suitable to use? You know, inside the body. So the radiation that we are using should be able to penetrate into the body. So the radiation that can penetrate deeper is gamma radiation. Alpha particle cannot penetrate even the outer body is covered with dead skin layers, so even alpha particle cannot penetrate that one. So the gamma radiation is less ionizing, we know that, but it can penetrate deeper. But it can ionize and it can penetrate deeper into the human body. So the correct answer is D. Question number 4. Correct answer D. Gamma radiation, because it is very penetrating. Okay, so question number 5. The next question number 5. It says that a mass oscillates with simple harmonic motion with frequency of 0.5 hertz. The amplitude of the oscillation is 0.3 meter. Which of the following is an expression for the maximum velocity in meter per second? We know that Vmax, the maximum velocity is given by A omega. A is the amplitude, or some books they use x naught omega. But and also we know that omega is equal to 2 pi times frequency. So here the amplitude is given as 0.3 omega 2 pi times frequency is given 0.5 hertz. So the answers are given in different formats. So the answer C is given as 2 pi times 0.5 into 0.3. So question number 5, correct answer is C. Okay, question number 6. Polonium-218 is a natural occurring radioactive isotope with half-life 185 seconds. A sample of this isotope contains 2.75 10 to the power 15 unstable nuclei. You know they are radioactive nuclei, unstable nuclei. Which of the following expressions can be used to determine the activity in Becquerel? So we should be able to find the activity in Becquerel means we can use A equal lambda n. Only thing we need to find the lambda. So half-life is given. We can use T half equal ln2 over lambda given in the data sheet. So lambda is equal to ln2 over T half. So half-life is given in seconds 185. So A equal lambda n. So that is ln2 over 185. And the unstable nuclei are the radioactive nuclei, that is 2.75 10 to the power 15. So the answer is given this one ln2 2.75. So that is the correct answer C. Question number 6, correct answer C. Okay, question number 7. A binding energy per nucleon against nucleon number or mass number graph is given. It's a standard graph. And we know binding energy per nucleon is equal to binding energy divided by number of nucleons. So binding energy per nucleon equal to binding energy divided by number of nucleons. Okay, so binding energy is the minimum amount of energy required to break the nucleus into individual free nucleons. Okay, that is the binding energy. Divided by number of nucleons is the binding energy per nucleon. Binding energy per nucleon is the minimum amount of energy required to remove one nucleon from the nucleus. So from the graph, the question is, which of the following is the energy required to split helium-4, He4? You know, helium consists of 2 protons, 2 neutrons. So helium consists of 4 nucleons. Required to split a helium-4 nucleus into 2 protons and 2 neutrons. So you are going to split it completely into individual 2 protons and individual 2 neutrons. From the graph, read and find out the binding energy per nucleon for the helium. From the graph, you can find it, that is 7.1 mega electron volt. That is the binding energy per nucleon. So the question is, which of the following is the energy required to split a helium nucleus into 2 protons and 2 neutrons? Means you are going to split it completely into individual 2 protons and 2 neutrons. Proton, proton, neutron, neutron. Like that individually you are going to split it. To remove one nucleon from the helium nucleus this is the energy required. So to remove all the 4 nucleons from the helium nucleus is the binding energy, that is into 4. So that will be equal to 28.4 mega electron volt. That is answer D. Okay, for question 8 and 9, this Hertzsprung-Russell diagram is given. Relative luminosity against temperature for cluster of stars. So Which of the following is part of a possible evolutionary path of a star? First one, W to Y. W to Y never happens along the main sequence. You know, this is the main sequence. Along the main sequence, there won't be any lifespan. There won't be any transition happens along the main sequence. So first one is wrong. Second one, X to Y. X to Y never happens. So you know, this is Y dwarf. This is red giant. So from Y it can come X, but or W can becomes X depending on the mass. It can become neutron star or black hole also. So never X to Y, but Y to X is possible. So the second answer is also wrong. Third one, Y to W. Y to W, I told that along the main sequence there won't be any transition, so that also wrong one. So the D part, Y to Z, Y to Z, that happens, a main sequence star will become red giant. So the correct answer for question number 8 is D. So the correct answer for question number 8 is D. Question number 9, that also we need to use this HR diagram, Hertzsprung-Russell diagram. Which of the following statements about stars in the positions W, X, Y, and Z is correct? First one, W and Y have the same mass. Never. W and Y won't have the same mass. You know, the temperature, temperature is increasing this direction. Along this way, temperature is decreasing. And the relative luminosity of W is much greater than Y, means relative luminosity is much higher, temperature much higher, means it has higher rate of hydrogen fusion is occurring. That means it has much larger inward gravitational pressure to increase the rate of fusion. That means it should have massive mass. W should have massive mass, and that's the reason it has higher rate of hydrogen fusion that produces higher luminosity and higher temperature. So W and Y won't have same mass. Actually, W will have larger mass than Y. Second statement, W has a lower surface temperature than Z. That also wrong, because you know temperature increases towards left or towards right, temperature decreases. So temperature of W is greater than temperature of Y. But when you consider Z, it's a red giant. So you know a star, when it becomes a red giant or supergiant, blue supergiant becomes blue supergiant, the temperature will decrease. So when you compare the W and Z, the temperature of W is greater than temperature of Z, but it says W has lower temperature, means it's a wrong statement. C part, Y is more massive than W. That also I already explained. W is massive than Y. The answer D is the correct one. It says Y has lower surface temperature than X. Y has lower surface temperature than X, means you know X is a white dwarf. In white dwarf, the temperature increases because after the explosion which causes planetary nebula, there won't be any outward radiational pressure. There won't be any further fusion reaction. So you know after the explosion, the star shrinks a lot due to inward gravitational pressure, and when the star shrinks a lot, its temperature will increase a lot. Okay, that causes white dwarf, and it emits faded light due to the temperature. So temperature of X, that is white dwarf, is greater than temperature of Y is the correct answer. So question number 9, correct answer is D. Okay, question number 10. This graph is given. It's about simple harmonic motion. An oscillator of mass m is oscillating, and its variation of acceleration with displacement is given by this graph. The question is, which of the following gives the period of oscillation in seconds? You know, the equation A equal minus omega squared x, and the gradient is in the form of omega squared is the gradient. So we'll find the gradient. So that is omega squared, that is 2 pi over t all the squared is the gradient. You know omega equal to 2 pi over t. That is equal to, you can find it this one, the gradients, minus omega squared, that is minus 3.2 minus 3.2 over 0.2 minus minus, so plus 0.2. So find it, that is 2 pi over t all the squared is equal to 6.5 4 over 0.4. So that could be 3.2 over 0.2. Okay, so t will be equal to, make the t subject, take the square root both sides, 2 pi over t will be equal to square root of 3.2 over 0.2. So make the t subject, t will be equal to 2 pi square root of 0.2 over 3.2. So that answer is given 2.0.2 over 3.2. Correct answer D. Okay, question number 11. Sirius is the brightest star in the night sky, and intensity of the Sirius measured to be 1.09, 10 to the power minus 7 watts per meter squared. Intensity, or it can be called as radiation flux, is given like that. And the luminosity of the star is given as 8.94, 10 to the power 27. The question is, calculate the distance. So you know the simple equation, F equal or I equal L over 4 pi d squared. Okay, intensity we know that, so d squared we need to find it. Intensity we know 1.09 into 10 to the power minus 7 equal 8.94, 10 to the power 27 over 4 pi times d squared. Okay, find the d, make the d squared subject and find the square root of it. That will be 8.08, 10 to the power 16 meters. Okay, question number 12. These are the data. I wrote it in detail. Okay, so here the time of boiling is given. So the mass of water 885. So the question says a kettle was used to heat 855 gram of water to boiling point. The initial temperature of the water is 21.5 and the final temperature it reaches the boiling point 100 degrees Celsius. The kettle is left switched on for 175 seconds. Until the water temperature increases to 100 degrees Celsius. So the specific capacity is given for the water, the latent heat of vaporization of the water given, the time of boiling. So after it reaches the 100 degrees Celsius, the water was let to boil for 175 seconds. The question is, find the mass of water boiled off. Okay, so here we assume the power of the heater given, or the power of the heater is constant. So first we need to find that. So first we'll use when the temperature of the water increases from 21 degrees Celsius to 100 degrees Celsius, you can see E equal mc delta T. We know energy is equal to power into time. The power is the power output of the heater or the flame, whatever it's given. P into T equal mc delta T. So power into time was initially 175. The time was initially 115 seconds. This is 115. The time taken to increase the temperature of the water from 21.5 to 100 is 115 seconds. This is the time of boiling, 175 seconds. So P into 115, the time is equal to, mass is 885. So convert to kilogram, 0.885 into specific heat capacity of water, 4190, into the change in temperature, 100 minus 21.5. So from that, find the power output of the heater. You will get 2.45, 10 to the power 3 watts. Now the same heat is used to boil the water. So power into time again is equal to L into latent heat of vaporization into mass of water vaporized. So 2.45 into 10 to the power 3 into 175, that's the time. LV is given 2.26, 10 to the power 6 into delta M. So find the delta M, that is the mass of water vaporized. That will be 0.189 grams, sorry, kilograms, 0.189 kilogram. Okay, so question number 13, alpha decay of thorium is given like this. Okay, and the masses of thorium, masses of radium, mass of alpha given in unified atomic mass unit in the table format. Show that the energy released in the decay is about 5.5 mega electron volt. So that we can do A part, question number 13, A part. We need to find the mass deficit or mass defect. Then we can use convert the mass defect will be when we calculate we will get it in unified dynamic mass unit, convert to kilogram, and you can use equal delta m times c squared. So we'll find the mass deficit. So that will be delta m is equal to mass of thorium minus mass of radium plus mass of alpha. You know the total mass of the product will be less than mass of the parent nucleus because the difference is converted to energy. What type of energy? Kinetic energy of both radium nucleus and the alpha particle, is it? So that we'll find it. Mass of thorium is given 228 point. Use all the decimal points given 02873 minus mass of radium 224.02021 plus mass of alpha 4.00260. So this will be 5.92 10 to the power minus 3 unified atomic mass unit. So we know one U is 1.66 10 to the power minus 27 kilogram given in the data sheet. So convert to kilogram, 5.92 10 to the power minus 3 into 1.66 10 to the power minus 27 kilogram. So that will be 9.83 10 to the power minus 30 kilogram. So energy release E equal delta M times C squared. When we use kilogram for the mass and speed of light 3 to 10 to the power 8, we will get it in joules. So we can directly convert to mega electron volt. So that will be delta M 9.83 10 to the power minus 30 into 3 into 10 to the power 8, all things squared. This will be joule. To convert electron volt, divide by 1.6 10 to the power minus 19. You know 1 electron volt is 1.6 10 to the power minus 19 joules. That's also given in the data sheet. To convert to mega electron volt, divide again by 10 to the power 6 mega electron volt. So when you solve, you will get 5.53 mega electron volt. Okay, B part. A textbook states that the kinetic energy gained by the alpha particle when a nucleus of thorium-228 decays is equal to 5.4 mega electron volt. We found that the energy release is 5.5 mega electron volt. That is the kinetic energy of radium plus kinetic energy of alpha, that is 5.53. I can say approximately 5.5 mega electron volt. So the textbook says, the question says that the textbook says out of this 5.5 mega electron volt released in this alpha decay, the alpha particle takes energy 5.4 mega electron volt. Most of the energy taken by alpha particle. That's the way the textbook is saying. The question is saying, comment on this statement. Your answer should include a calculation. Okay, so we know that in this decay, something related to momentum. So you know that we can imagine the decay of alpha particle as an explosion in momentum. You know, we learned a topic, explosion in momentum. So we can imagine it as an explosion. Initially, the thorium nucleus was at rest. So that means its initial momentum is 0. You know, in alpha decay, what you learned in unit 4, like charge is conserved, total mass energy is conserved, baryon number conserved, lepton number could be conserved. Then we know that momentum also must be conserved. So momentum is conserved. This momentum, thorium, initial momentum 0 means Momentum of radium plus momentum of alpha must be equal to 0. So we can see that since the thorium was initially at rest, its total momentum is equal to 0. Therefore, the momentum of radium and momentum of alpha after the decay when we add, it should be equal to 0 means they should have the same magnitude of momentum in opposite direction, is it? So we can say that since is at rest, its momentum equal to 0. Total momentum is conserved. So I can say momentum is denoted by P. Momentum of radium is equal to minus momentum of alpha. They have the same magnitude and the minus sign indicates they move in opposite direction. We know that kinetic energy is given by P squared over 2m. We learned that in momentum in unit 4. So kinetic energy is given by P squared over 2m. So I can say kinetic energy of alpha plus kinetic energy of radium, that is equal to 5.5 mega electron volt. Instead of kinetic energy of alpha, I can say P squared alpha. I can use this one, P squared alpha over 2 times mass of alpha plus P squared radium over 2 times mass of radium is equal to 5.5 mega electron volt. Okay, so it's like when we add these two, we are getting 5.5 mega electron volt, but momentum of alpha is equal to momentum of radium. That means since mass of alpha is much smaller than mass of radium and momentum of alpha is equal to momentum of radium, what's going to happen? The most of the energy is going to transfer to the alpha particle. You know that the denominator, when we consider this, is much smaller than mass of radium. The numerator will have the same magnitude, means this quantity will have a larger value. We can show that. So we know that the total energy released 5.5 mega electron volt will be divided across the alpha particle and radium according to the ratio of these two quantities. So I can say kinetic energy of alpha over kinetic energy of radium. The ratio I'm finding, P squared alpha and P squared radium are same. So I can say instead of this one, I can say P squared alpha over 2 times mass of alpha into, you know, that will go up 2 times mass of radium over P squared radium, but instead of P squared radium, I can say P squared alpha because both have the same momentum, both have the same magnitude. So instead of P squared radium, I can again put P squared alpha. So that is going to be mass of radium over mass of alpha. That is kinetic energy of alpha to kinetic energy of radium will be at the ratio of mass of radium to mass of alpha. Mass of radium is given in the data sheet, given in the question, that is 224.02, I can say 0. Mass of alpha is 4.00, so that is going to be 56. So mass kinetic energy of alpha will be 56 times of kinetic energy of radium. Okay, so kinetic energy of alpha will be 56 times of kinetic energy of radium. So that means we know that kinetic energy of alpha plus kinetic energy of radium is 5.5, but kinetic energy of alpha is 56 times of kinetic energy of radium, means we know how to calculate the kinetic energy of alpha. So I can calculate like this, the kinetic energy of alpha. So we know that the kinetic energy will be divided across alpha and radium 1 is to 56, right? So that's alpha will have the 56 times of kinetic energy of radium. So from this I can say kinetic energy of radium is equal to 1 over 56 of kinetic energy of alpha. Use this one, kinetic energy of alpha plus 1 over 56 times, 1 over 56 times of kinetic energy of alpha will be 5.5 mega electron volt. So you know that is 56 plus 157 times kinetic energy of alpha over 56 equal 5.5. Find the kinetic energy of alpha, that is 56 into 5.5 mega electron volt over 57, that will be almost 5.4 mega electron volt. Okay, question number 14a part. These are questions related to gases. Natural gas produced from landfill consists of a mixture of methane and carbon dioxide. At temperature of 20 degrees Celsius, it consists its pressure is 1.01 10 to the power 5 Pascal, and the 1 mole of carbon dioxide volume is 0.0241 meter cube. Question is, show that the number of molecules in 1 mole of carbon dioxide. Okay, so we can use the equation PV equal NKT. So pressure is given 1.01 10 to the power 5. Volume is given 0.0241. We need to find number of molecules. K is the Boltzmann constant given in the data sheet, that is 1.38 10 to the power minus 23 into the temperature 20 degrees Celsius should be written with Kelvin. So that is 220 plus 273, 293 Kelvin. So find the N. You will get 6.02 10 to the power 23. Okay, so we know that this is the question 14b part. In a sample of natural gas, the RMS velocity of the carbon dioxide molecule is 60.5 percentage of RMS velocity of the methane molecule. So if I take for methane, the RMS velocity square root of this notation, if I take it for CO2, that should be 65 percentage of this one means 0.605 of this one. So that is the RMS velocity of CO2, 65 percentage, 60.5 percentage, that's given in the question. RMS velocity of CO2 is 60.5 percentage of RMS velocity of methane. So if I take the RMS velocity of methane is this much, so this is the way we should write for carbon dioxide. The question is, deduce the ratio of mass of carbon dioxide molecule. So mass of CO2 over mass of methane, we need to find the ratio. Okay, we know that at a particular temperature, the average kinetic energy of a molecule is equal to 3 by 2 kT. So at the same temperature, for any type of gas molecule, the average kinetic energy of the molecule will be depending only on the temperature, absolute temperature. So whether it's a carbon dioxide or methane, when they both are at the same temperature, their average kinetic energy of the molecule will be the same. So I can say average kinetic energy of the carbon dioxide molecule will be same as average kinetic energy of methane molecule at the same temperature, because the average kinetic energy does not depend on the mass of the molecule. So I can equate the average kinetic energy of carbon dioxide and average kinetic energy of methane molecule. But we know that average kinetic energy is given by half m mean square speed. Half m mean square speed equal 3 by 2 kT. So temperature same means both will have the same average kinetic energy of a molecule. So I can say kinetic energy, average kinetic for CO2, mCO2 or I can say mCO2 into its mean square speed. Its mean square speed for CO2 is 0.605 into square root of all things squared is equal to, this is for carbon dioxide, average kinetic energy of a carbon dioxide molecule will be same as average kinetic energy of methane molecule because at the same temperature. So for the methane molecule, half mass of methane mm into square root of c squared squared. This is the RMS speed, square of it. Okay, so solve it. Half will get cancelled. So here mCO2 times 0.605 squared into c squared equal mm c squared. So c squared will get cancelled. The question is find the ratio of mass of CO2. So mCO2 over m methane will be equal to 1 over 0.605 squared. That will be 2.73. Okay, question number 50. Nuclear fusion in the core of star is the source of the star's power output. Explain the conditions required to bring about the and maintain nuclear fusion in stars. It's a very common question. Several times this question appeared. So first you should say, to have fusion reaction, the hydrogen nuclei should get closer to each other. So if they want to fuse, they should join together, is it? So they should get closer to each other. That means the distance should become zero. So when the hydrogen nuclei get closer to each other, there will be very large electrostatic repulsive force. So they should be able to overcome that electrostatic repulsive force. And if they want to overcome that electrostatic repulsive force, the hydrogen nuclei should have very large kinetic energy. We know that when the temperature increases, kinetic energy will increase. So to overcome the electrostatic repulsive force, they should have very high kinetic energy. To have such much larger kinetic energy, the temperature should be very high. The first condition we can say, we can explain the first condition like that, to overcome the electrostatic repulsive force. So we can start like this, to overcome the electrostatic repulsive force, or we can start like this, when the hydrogen nuclei get closer to each other, there will be much larger electrostatic repulsive force. To overcome this electrostatic repulsive force, they should have much larger kinetic energy. And to have such larger kinetic energy, the temperature should be very high. Okay. Next, what is the condition? The rate of collision should be very high to sustain the fusion reaction. So to sustain, to keep the fusion going on, the rate of collision should be very high. To have such higher rate of collision, the hydrogen nuclei should be very closer to each other. They should be packed very closer to each other. That means they should have very high density. How can they get it? They should have higher density that will give much larger inward gravitational pressure, and due to much larger inward gravitational pressure, the hydrogen nuclei will be get closer to each other. That will help to have higher rate of collision to sustain the fusion reaction. Okay, so question number 16, this is about spin of sun. Sun is spinning, and we observe the sun from Earth like this, and the electromagnetic radiation wavelength of the electromagnetic radiation of hydrogen spectrum lambda A, alpha spectrum of the hydrogen, is measured from Earth At three different points of the sun, A, C, and B, the wavelengths are given like this. The question is, fill the points. Which wavelength belongs to which point? You know that the earth is spinning like the sun is spinning like that. The direction of spinning is given like this. So when we see from earth, this point A is coming out of us. You know, if it is spinning like this point where this is the point A, it's coming towards the observer. We are observing from here. Say like this, we are observing from here. So when it is spinning this direction, A is coming towards us and B is going into or away from us. So according to Doppler effect, the wavelength of the same spectrum, light from the same spectrum, alpha spectrum of the hydrogen lambda A, here we will receive the spectrum with larger wavelength according to Doppler effect. B is moving away from us. A will have a lower wavelength because it's moving towards us. So here when we consider what are the points, we can say this point has the largest wavelength 2837. So this should be the B. Now, this one is the lowest because it's moving towards us. So this should be A. And this is C. You know, the center has no relative motion when we observe from Earth. No relative motion due to spin because center part. So these are the names. B is moving away from us into the board. So larger wavelength. A is moving out of the board towards us, so smaller wavelength, and this is relatively to us, no motion, center part, so no relative motion due to spin. So B part, this is the answer for the A part. We fill the table, A part. B part, explain why there is a variation in the wavelength of the light from different points on the sun. So I don't need to write it, already I explained that. You can say when we observe from Earth, the point B is moving away from us and point A is moving towards us. So according to Doppler effect, there will be relative velocity. Therefore, B will have increase in wavelength and A will have decrease in wavelength. So that should be the answer. Refer the Doppler effect also. That's the answer for the B part, question number 16. Question number 16, C part. In the laboratory, the wavelength of the alpha line in the hydrogen spectrum is given as 6562797. So you can see that C, I told that point C, when we observe from Earth, there is no relative motion when we observe from Earth due to spin. So the wavelength that we receive from center of the sun will be same as the wavelength of the same alpha spectrum of hydrogen when we get it from the laboratory, right? So that is given page number 15, question number C part. They are saying in the laboratory the wavelength of the alpha line in the hydrogen atom spectrum is 657.2797. So that's the actual wavelength. Assess whether this is consistent with the sun having a period of rotation approximately equal to 28 days. Radius of the sun is given and 1 day is equal to 86,400 seconds also given. So we need to show the time period of spin of the sun is 28 days. So we can use the Doppler effect equation, delta lambda over lambda equal V over C. So delta lambda I can use either B or A. So I will use for B, if I consider the radiation wavelength from the B 656.2837 minus this wavelength 656.2797 over the actual wavelength 656.2797 equal V over 3 into 10 to the power 8. Find the speed of the spin. So that will be the linear speed will be 1828.5 meter per second. So we know that V equal R omega and omega equal 2 pi over T. So find the time period. So time period will be 2 pi into radius given, radius of the sun 7 into 10 to the power 8 over the speed 1828. So in seconds that will be 2.41 10 to the power 6 seconds. To convert to hour, divided by 1 day equal this much. To convert to days, divide this by this value 2.41 10 to the power 6 divided by 86400. So that will be 27.9 days. Okay, question 17 about trigonometric parallax method. So astronomers use a variety of techniques to determine the distances to astronomical objects outside our solar system. Describe how trigonometric parallax can be used to determine distance or to a nearby star. Okay, so there we use like this. Question number 17. This is the sun. Earth is orbiting around the sun. So we use radiation from far distance galaxies or the light from far distance galaxies as reference line. You know, when we are measuring an angle, we need a reference line. So light from far distance galaxies will be parallel where the earth is here or even when the earth is here. Say for example, if the star is somewhere here, far distance star or far distance galaxy, if you use it as a light from it as a reference line, the light which is coming from far distance galaxy, if I draw a line from here to here, this star, far distance star, and if I draw even after 6 months when the earth is here, exactly after 6 months when the earth is here, if I draw or consider light from far distance galaxy, so if I consider now these two lines, they looks like almost parallel, is it? So normally we take light from far distant stars as a reference line. So we need first focus the telescope to far distant star and now take it as a reference line. Now focus the star to nearby star. So measure the angle. So take measurements from here to the star. Then after 6 months, the earth will be here exactly in opposite side. So take the measurements. These are the reference line from the far distant stars, the light. So they'll be almost parallel. So this, if I say theta 1 and this is theta 2, this angle will be theta 1 plus theta 2. Is it? So this is green color lines are the light from far distance galaxies. So that light will be used as the reference line to measure the angle. So if this is theta 1, this measurement, this is theta 2, this angle will be theta 1 plus theta 1 plus theta 2. So theta 1 plus theta 2 is called angular displacement or arc difference during 6 months period. So nearby star is here, earth is here. After 6 months, earth will be here. So by using these two measurements, theta 1 and theta 2, we can measure the angular displacement or arc difference made by the nearby star during 6 months interval. And we know the diameter of the earth orbit around the sun, that we know that. So by using trigonometry, we can find the distance of the nearby star from the sun or from the earth. Okay, question number 17b part. Explain how a knowledge of distances to distant galaxies has enabled astronomers to determine a value for the age of the universe. Okay, now we should be able to measure the, all the galaxies are moving away from us. All the galaxies are receding from us. So by using the red shift, when they move away from us, there will be red shift in their absorption spectrum. So by using the red shift and by using Doppler effect, we will be able to find the speed of recession of different galaxies. Now, if we know the distance of those galaxies, then we can plot a graph of speed of recession against distance of those galaxies. It will be almost a straight line. The best fit line will be straight line. Find the gradient of it. That's the thing Hubble did. So find the gradient of the speed of recession against distance graph. The gradient will be the Hubble constant. So 1 over Hubble constant will be the age of the universe. Okay, question number 18. A website advertises a baby crib that can be hung from a spring. The crib head can be set into vertical oscillation. So the instructions for the crib state that the crib can be support a maximum mass of 15 kilogram. When the crib supports a mass of 15 kilogram, the spring extends by 42.5 centimeter. Show that the stiffness, stiffness means the spring constant K. So that is very simple. We can say 18A part, first part, you can use F equal K times delta X. So that is 15 kilogram. It's hung vertically. So hung vertically means 15 into 9.81 is the force acting on it. K into the extension is 42.5. So 42.5 into 10 to the power minus 2 meters. So K will be 346.2 Newton per meter, approximately 350 Newton per meter. That is the A part, first part. A part, second part, it says a baby is placed in the crib and the spring extends to bring the system to equilibrium in a vertical alignment of a spring. When you attach a weight, it will extend in vertical plane. The crib is displaced through a small vertical displacement and released. State why the crib will oscillate with simple harmonic motion. So you can say during the oscillation, the resultant force acting on the mass will be always towards the equilibrium position. Therefore, acceleration also always will be towards the equilibrium position. Next, we should say always the acceleration is directly proportional to the displacement from the equilibrium position. So, if you want to state an oscillation is simple harmonic motion, the two conditions that you can find in any books, they say first condition, the acceleration should be directly proportional to displacement. From the equilibrium position, displacement is measured from the equilibrium position. So acceleration must be directly proportional to displacement from the equilibrium position. Second condition, the direction of the acceleration always point towards the equilibrium position. So these are the two conditions. Here also you need to explain, you need to state. Third part, the baby has a mass of 7.25 kilogram. Calculate the period of oscillation of the crib. Mass of the crib is given 2.55 kilogram. Stiffness of the spring, that is K, is given 350 Newton per meter. You know that there's an equation, third part, T equal 2 pi square root of M over K given in the data sheet. So 2 pi square root of M means the total mass. That will be mass of the baby plus mass of the crib over the stiffness, that is 200, spring constant 350. So solve it. You will get the answer 1.05 seconds. That is the third part, A part. Question number 18. Okay, question number 18, B part. The maximum mass that the spring can support before being damaged is 25 kilogram. That means if you just hang the spring, so just hang the spring, and if you attach a weight, it will extend, and the maximum mass that can be attached is 25 kilogram when it is just at rest. So during that time, the tension will be equal to 25 into 9.81 Newton when it is just hanging, right? Explain why the instructions state that maximum mass is only 15 kilograms. So actually, the spring will get damaged for 25 kilogram, but when you are oscillating by attaching a mass to the spring and when you are oscillating it, the maximum mass could be not 25, less than 25. Why is it like that? That's a question. So you can say that during oscillation, the spring will go below the equilibrium position. Now here you can see when it is at equilibrium position, the tension is equal to weight of it. So the maximum tension could be without damaging or almost at the border of damaging 25 into 9.81. So if you pull it further, it will have oscillation down and up. So the displacement or the extension of the spring will become more than static extension. So the tension will become more than this maximum tension. So certainly it will break. So even if you have 15 kilogram, when it oscillates, the extension, when it increases below the equilibrium position, the tension will increase and the tension can become equal to this tension. So that's the reason the mass that could be attached to the spring when it oscillates, the maximum mass that could be attached to the spring when it oscillates must be lower than the maximum mass that could be attached when the spring is at rest at the equilibrium position. Okay, question 19. Cobalt-60 is a source of gamma radiation. Gamma radiation can be used to sterilize medical support, and this reaction is given and they asked to balance and put the values. We should know beta minus is 0 minus 1, so balance it. So it should be 28 and this would be 60. B part, A part, first part is this part. A part, second part suggests why the majority of the energy released is shared between the beta minus particle and the antineutrino, not to the nickel, right? So here the same thing, like it's just a 1 mark question, but we can say here the initial momentum equals 0. Moment of the cobalt is equal to 0, so the total momentum must be equal to 0. But here we can simply say the particles beta minus and neutrino, anti-electron neutrino, has much smaller mass compared to mass of the nickel. So most of the energy released will be shared among the particles. They have the lowest mass, right? So we can say since the mass of or total mass of beta minus and anti-electron neutrino is much smaller than the mass of the nickel. Therefore, the most of the energy will be given to both, right? That is enough for this part. You have to answer in terms of mass. Lower the mass, higher the energy they will have during this type of nuclear reactions. Okay, B part, question 19. The activity of the cobalt is given. When used for sterilizing, the source is replaced with the activity drops below 1.85 10 to the power 14. So we can have cobalt 60 initial activity 4.07 10 to the power 14. So this cobalt element could be used to sterilize until its activity drops to 1.85 10 to the power 14. So half-life is given in years and 1 year how many seconds is given. So calculate the time in years until the source could be replaced. So we should calculate the time taken by the activity to drop from 4.07 10 to the power 14 becquerel to 1.85 10 to the power 14 becquerel. So that is simple question. So B part, we can say A equal lambda n. I am going to use, sorry, I'm going to use A equal A naught e to the power minus lambda t. First, I need to find the half-life. From that, I am going to find the lambda. So T half is equal to ln2 over lambda. So find the lambda, ln2 over, I'll keep the half-life in here, so I'll get the lambda in per year. So that will be 5.27 half-life. So I will get 0.132 per year, e to the power minus 1. So then activity is dropping. So A equal A naught e to the power minus lambda t. So initial activity is given 4.07 10 to the power 14 BQ into e to the power minus lambda is 0.132 t. So I'm keeping this in per year. So time will be in year. So after certain time, which is in year, because this is in per year, means this should be in year, right? So when I solve the equation, I'll get the answer in year because lambda is written in per year. So the final activity becomes 1.85 10 to the power 14. So that's all physics. Now we need to use maths, simple maths. The time will be in here. So you know how to solve this. E to the power minus, I can write 1 over e, cross multiply. So I can say e to the power 0.132 t is equal to 4.07 into 10 to the power 14 over 1.85 10 to the power 14. So from that you will get it calculated e to the power 0.132 t will be equal to 2.2. Take both sides natural logarithm. When we take natural logarithm, it will be 0.132 t will be ln 2.2. Find the t ln 2 sorry ln 2.2 over 0.132, that will be 5.97 years. Since this is in per year, the time will be in years. Okay, so C part, when in use the cobalt 60 source is shielded with lead. The graph shows how the transition of gamma radiation depends upon the thickness of X, the lead shielding. So here the x-axis is thickness of the lead, X in centimeter. This is the percentage gamma radiation transmitted, what percentage will be transmitted depending on the thickness. So the graph is slightly different. You can see this is 1%. From between 1% and 10%, there are 9 lines. So this is 1%. The second line indicates 2%, next line 3%, 4%, 5%, and up to 10%. See the graph. Then from the 10%, the line next one is 20%. Then 30%, 40%, 50%, up to 100%. So that's the way uneven gaps are given, but that's the way we should take the values of the y-axis. So 1%, next line 2%, next line 3%, next line 4%, up to 10%. From 10% to 100% on y-axis, the line next to the 10% will be 20%, next line will be 30%, 40%, 50%, up to 100% is shown. The count rate from the source must be reduced from 4 into 10 to the power 14 BQ to 1.2 10 to the power 14 BQ when we are using it for maybe the safety reason. Deduce whether lead shielding of thickness 1 centimeter would be sufficient to achieve this. So that means in this question they are saying for safety reason there should be a lead shielding. So that should reduce the gamma radiation, the activity from 4 into 10 to the power 14 BQ, 4 into 10 to the power 14 BQ to 1.2 into 10 to the power 14 BQ. So what thickness of lead should I use to reduce the gamma radiation from this becquerel to this becquerel. So we will find the percentage drop. So I can say percentage reduction or percentage transmission. So from this to this I should reduce. So percentage transmission equal to 1.2 10 to the power 14 over 4 into 10 to the power 14 into 100%. That will be the percentage of transmission. This is the actual activity of the cobalt source, but I need this much to transmit. What percentage should be transmit? I am calculating. So the percentage of transmission will be 30%. So from the graph, this is 10%, next line 20%, next line 30%. From the graph, for the 30%, find the thickness. You will see that will be 1.1 centimeter. See the graph, that will be 1.1 centimeter. So the required thickness will be 1.1 centimeter. So 1 centimeter is not suitable. Okay, so question number 20. The sun is a main sequence star. A part. Question number 20. A part. State what is meant by main sequence star. You can say a star that has hydrogen fusion or significant amount of hydrogen fusion in its core. The word core must be there. Hydrogen fusion must be there. Core must be there in your answer. Right. B part. The sun will eventually leave the main sequence and become a red giant star. Luminosity of sun is given 3.83 10 to the power 26. Show that the current radius of the sun. Okay, so B part, first part, question number 20, B part, first part, we can use L equals sigma A T to the power 4, and we know the surface area 4 pi r squared. You know that for a sphere, that area is given by 4 pi r squared. That is not given in the data sheet. You must remember that. So substitute the values. L is given, luminosity is given 3.83 10 to the power 26. Sigma is given in the data sheet. Stefan Boltzmann constant 5.67 10 to the power minus 8 into 4 pi r squared into temperature should be in Kelvin, that is given 5780 to the power 4. Solve it and find the radius. We'll get 6.94 10 to the power 8 meters. Okay, B part, second part. As a red giant star, the radius of the sun will be about 150 times its current radius. So, you know, when a main sequence star becomes like a sun-like star or low mass star, when it leaves the main sequence, it will become red giant. So the radius will increase, temperature will decrease. So since the temperature decreases, the peak wavelength of the emitted radiation will increase. That's the reason it becomes red color. So they are saying the luminosity will become 1,600 times because of the surface area increases heavily. The luminosity will become 1,600 times of the current luminosity of the sun, and the radius will become 150 times of the present radius. So the question is, lambda max is the wavelength at which peak power radiation occurs when it becomes a red giant. Show that when the sun is in its red giant stage, lambda max, we need to find it. So you know that again I need to find, so temperature of the red giant I need to find. So temperature of the red giant I can find by using again L equal sigma A T to the power 4. L, they are giving 1,600 times of the present luminosity. So 3.83 10 to the power 26 times 1,600. It's given in the data in the question 1,600. Sigma, we know that 5.67 10 to the power minus 8. 4 pi r squared, because surface area, radius will become 150 times, so that should be calculated like this. We should find the new radius. That is so that will be 150 times 7 into 10 to the power 8 all things squared into t to the power 4. I need to find the temperature of the red giant when sun becomes red giant. So solve it and take the fourth root of it. Find the temperature, that will be in Kelvin. So you will get 2972 2972 Kelvin. The question is, I need to find the maximum wavelength when emitted by the red giant when our sun becomes red giant. So use the Wien's law, lambda max times T is equal to Wien's constant 2.898 10 to the power minus 3. So lambda max into T 2972 equal 2.898 10 to the power minus 3. You will get lambda max will be equal to 0. You'll get 9.75 10 to the power minus 7 meter, but they also show that 1 into 10 to the power minus 6, so I can write it 0.98 into 10 to the power minus 6 meters, right? So that is approximately 1 into 10 to the power minus 6 meters. Okay, question number 20. B part, third part. At this stage, that means when it becomes red giant, at this stage of its evolution, the sun will be classified as red giant star. The wavelength of red color, you know, it will become red color. So the wavelength of the red color is given, that is 6.2 10 to the power minus 7 meter to 7.8 10 to the power minus 7 meter. You can check it anywhere, internet or any other books. It says 620 nanometer to around 780 nanometer. That's a red color range. But here we got 9.75 10 to the power minus 7, 9.75 10 to the power minus 7 meters, not in this range when we calculated. The question is, comment on the value of lambda max and this classification of the sun. So we can say like this: the peak wavelength is not within the visible range of red color. It's outside, it's larger than this one, means it should be infrared radiation. So we can say the peak wavelength when it becomes red giant is infrared radiation, because larger than this range of red color. This is the range of red color, so that is in the infrared radiation, we can say. And you know that normally with lambda max, some of the radiations also will be emitted. Okay, C part. And as the sun continues its evolution, its mass will decrease. It's estimated that at its largest radius, the mass of the sun will have decreased significantly. That means when it becomes a red giant, its mass will decrease significantly. Explain how the orbital period of planet would change as the mass of the sun decreases. So, you know, Earth is orbiting around the sun. How the period of orbit of the Earth around the sun will change. Assume the radius or the distance of the Earth from the center of the sun is not changing. So we can use like the, you know, F equal the centripetal force, F equal mr omega squared is given by the gravitational force between the sun and the Earth. So that will be G m over r squared. So here the m, symbol m, is the mass of the Earth. Capital M is the mass of the sun. So both side m will get cancelled. Omega squared equal gm over r cube, where m is the mass of sun, The capital M, symbol M is the mass of the Earth. We know omega equal 2 pi over T. So 2 pi over T, all things squared equal Gm over R cube. And make the T subject. T equal or T squared equal 4 pi squared over Gm into R cube. So here the period of the Earth's orbit around the Sun is given by this equation, and they are saying the radius of the Earth's orbit around the Sun is not changing, it's remaining the same. Only the mass of the Sun is decreasing, all of the factors remaining the same. Therefore, I can say T squared proportional to 1 over m, or T is inversely proportional to m. So when the mass increases, therefore when m decreases, T will increase. So the time period of the Earth around the Sun will be more than 1 year. Okay, question number 21 about the satellite motion around the Earth in two different possible paths. One is equatorial orbit, so that is above the equator, it's moving. This is across the polar orbit path. So the weather satellite in polar orbit circles the Earth at a height of 8.50 10 to the power 5 meter above the surface of Earth. Show that the gravitational potential at this height is about minus 5.5 10 to the power 7 joule per kilogram. Mass of the Earth is given. Radius of the Earth is given. So height is given. So we know the equation for gravitational potential. Question 21, if 1, gravitational potential V equal minus Gm over R. So R is the radius of the orbit, minus 6.67 10 to the power minus 11. Mass of the Earth is given 5.98 10 to the power 24 over R is the radius of the orbit, means height plus radius of the Earth. So that is 6,360 is the radius of the Earth in kilometer, convert to meter, plus height is 8.50 10 to the power 5 meters. So the potential will be minus 5.53 10 to the power 7 joule per kilogram. Okay, second part, question number 21, A part, second part. Hence, calculate the increase in gravitational potential energy when the satellite is placed in orbit. So, potential energy is given by, gravitational potential into mass, is it? So, change in gravitational potential energy, change in gravitational potential energy is equal to change in gravitational potential V2 minus V1 into the mass of the satellite. So change in gravitational potential into mass is the change in gravitational potential energy, because potential into mass gives the gravitational potential energy, right? So V2, so the gravitational potential energy at the final position is given minus 5.53 10 to the power 7 minus the gravitational potential on the surface of the Earth is given 6.27. So into the mass of the satellite is given as 4,990 kilogram. Solve it, you will get the answer. That will be 3.69 10 to the power 7 joules. That is the increase in gravitational potential energy. Okay, question number 21, B part. It is claimed that a satellite in orbit at a height of 8.50 10 to the power 5 meter would make 15 orbits of the Earth every 24 hours. Assess the validity of this claim. Okay, again, I'm going to get the equation T squared equal to 4 pi squared or Gm into R cube as earlier. So anyway, question 21B part. I know the centripetal force is given by mr omega square, that is the gravitational force between the earth and the satellite, mass of earth, mass of satellite. So this is mass of satellite. Mass of satellite is the smaller m over r square. R is the radius of the orbit. So m and m get cancelled, r comes here. So omega squared equal gm over r cube. Omega equal 2 pi over t, all things squared equal gm over r cube. So I can say t squared equal 4 pi squared over gm into r cube. So I need to find the time period. 4 pi squared into r cube. I need to find the radius of the orbit. So the height is given 8.50 10 to the power 5, and the radius of the earth is given 6,360 kilometer, convert to meter. So we can write that 63, the radius of the earth can be given as 63.6 plus 8.50. I'm putting everything in 10 to the power 5 all in cube. So this is the radius of the earth. 63.6 into 10 to the power 5 meters is the radius of earth. 8.50 into 10 to the power 5 is the height above the radius of earth, above the surface of earth, height of the satellite, into cube over gm. G is 6.67, 10 to the power minus 11, mass of the earth, because they are orbiting around the earth, so mass of the earth 5.98, 10 to the power 24. From that, find the period t. You will get it in seconds. That will be 6,091 seconds. Okay, how many times it will orbit? So number of orbits in 24 hours. During 24 hours, convert 24 hours into seconds. So 24 into 60 into 60 seconds. This is the time for one orbit. So divide by 6091, you will get 14.2, which is not equal to 15, is it? So it's a wrong claim, or the statement is wrong. You have to give that the claim is not correct. Okay, the last part. Here, give one advantage and disadvantage of placing a weather satellite in a polar orbit rather than in the suggested equatorial orbit. So you can say that now advantage of keeping in polar orbit is it can cover more regions. So if polar orbit, so if it is equatorial orbit, it can't get any information from the polar far distance. So the satellite which is orbiting across the polar of the polar region of the earth, advantage is it can cover more of the earth's surface and passes close to polar region also. The disadvantage, now it will not be monitored always, or the data cannot be obtained from the polar orbit satellite. Okay, because you know the satellite communication, everything are used by equatorial orbit. But if it is a polar orbit, you won't be able to get the data always, right? Okay, so that's the end of discussion of this October 2021 IAL Unit 5 physics paper. Okay.